Ashlyn here to take you inside the lab. So our lab's doors are closed, but we still would like to show you the exhibits we have in here. Here in the Inspiration Hub, where I am now, we have lots of exhibits about energy, technology, motion, and more. I am at our air rockets exhibit right now. Who likes rockets? I sure do. It's so much fun to see a rocket launch into the air. Typically, those really big rockets that launch use fire to launch way up into outer space. Today, we're not going to use fire because we want to stay safe. And we're also not going to go into outer space, but we will go pretty high up all the way to our ceiling. So I mentioned how rockets use fire. Today we're not using fire, but a different sort of pressure or force to make our rocket move. Now the most important thing to know about rockets is Newton's third law of motion. Now Newton's third law of motion tells us that every action has an equal and opposite reaction. So say you push your brother and he'll push you back, right? Or you push up against a wall really hard and you get pushed back. Same thing with a rocket. If the fire is pushing out in one direction, the rocket will go up in the other direction. Or if you kick a soccer ball, you make it go in one direction and you feel that back in your foot, right? So we're going to use Newton's third law to launch our rockets into the air using air pressure. Air is a gas that is all around us. You can look around and see it. Well, actually you can't normally see it. Air is normally invisible, but gas and air will move around. The wind, a balloon, right? And all that air we want to try and bring together to make it go in one direction. So imagine a big gust of wind in one direction, maybe pushing or blowing you over, right? We're going to try and use the wind to get the rockets to go up, the wind or air. So we need to compress this air all together. Let's try compressing the air with our hands. Did that work? Did I trap the air and compress it all in here? No, not really, right? That air wants to escape. It wants to move around. So we have a sort of pump to help us do that. You may have seen a bike pump at home where you can pump with your hands or with your feet, or an air compressor at a gas station to put air back in a tire. This is pretty similar to that. It's a machine that will bring air together and push it all in one place. And it will use my energy to do that. So you can see there is a wheel here attached to an axle. This is a simple machine that helps us move things. In this specific exhibit, it moves these pumps up and down to compress our air. So you can see as I spin, these pumps are going up and down, and they are loading up the PSI, which is a measurement of air pressure. PSI stands for pounds per square inch. So right now I'm at 10 PSI. Picture 10 pounds of air. Right now in my hand, I'm not even holding 1 pound of air. How can I get 10 pounds of air? I can't using just my hands. But with a pump, we can kind of suck or push the air all together. So 10 pounds of air is a lot of air. Imagine a fan blowing at you. That's say maybe 2 pounds of air. But 5 pounds of air is a lot, 10's even more. And I can go all the way up to even 30. Now all this air is compressed and pushed in one area and comes out here through this little gray tube. When I push this big red button, the air is released. Did you hear that? It all got released at once. Versus if it was released really slowly, there wouldn't be a lot of pressure. It wouldn't be pushing very much, right? Picture a balloon. You blow up a balloon. it gets really big. You let it out all at once, it goes everywhere, and the balloon flies everywhere. Versus if you let it out really slowly, it doesn't make a loud noise, and it doesn't really move very much, right? It's all about how much we have at a time. So again, this is PSI, or pounds per square inch. So in an inch of area, how much air do we have? So I have some different bottles here for us to launch. I have different sizes and different shapes. And what I can do is test the different bottles to see what works the best. So I'm going to try this nice short and wide bottle first. I'm going to put it in here, and I'm going to try 15 PSI. So I will spin this wheel and press the button. All right, that one about to here, right? Let's see if we can get it even higher than that. So 15 was about half of what we can go. So I will go to 30 next. So you can see as I'm spinning the wheel, I'm using my muscles and my energy to put energy in here. And the energy in here, again, is air pressure. We use it to blow up tires, balloons, fly kites, move things around. You can actually use air pressure to clean things too. All right, whew, 30 PSI. Let's try this time. Ready? Whoa, that went so much higher. It still didn't go all the way to the top. Let's see if I can get it all the way to the top. So I have some differently shaped bottles. Let me try this one. It's taller, a different shape, and a really big opening right here. All right, I will try this one at 15 PSI, same as I started the last one on. All right, 15 PSI, ready? Oh man, that didn't even do that much, right? It just went a little bloop. But when I used this one at 15 PSI, it went all the way to here. Why did it do that? You may notice the difference between these two bottles. This one has a much bigger opening. So when I put it on the gray tube right here, some of the air is able to escape out the sides. So not all of the air is concentrated in one area. Remember, air likes to take the shape of its container. So the room that we're in right now, the air wants to go everywhere. Versus if there's a tight seal on here, all of the air will go in one place, specifically to the top of the bottle to launch it upwards. All right, let's try. I have this one, has the smallest opening yet. A nice long thin shape and kind of the same shape all around, right? Let's try that. And again, 15 PSI, just like our first two bottles. So I'll give it a couple spins to compress that air. All right, now I'm going to try this one. Oh my gosh, that went so fast. This one went all the way to the ceiling. So in between our different bottles, we learned that one with a smaller opening works better. Now, you might not have something like this at home to help you compress the air, but you can use other types of gas or air pressure to shoot it in the air. Baking soda and vinegar will combine to make carbon dioxide, or CO2, a gas that creates that fizzing reaction. So maybe you could try baking soda and vinegar in a bottle and see if you can get that to launch. Or blow up a balloon. Try it out. And next time, come to the Children's Science Center lab and try it out here. Try the different bottles, PSI. Maybe we could even add fins and a nose cone to our rocket. All right, I hope you enjoyed seeing our air rocket launcher here at the Children's Science Center lab, and we're excited to see you next time for our Inside the Lab.